Okay, so now that we don't have to do the limit definition to find the derivative, we've got our rules for sine and cosine. We have a power rule for polynomial type functions. Now we're going to make a shortcut rule for when we have two functions that are not of a polynomial form, meaning it's like maybe two polynomials multiplied together, or any two type of functions multiplied together. So if our function is defined as one function times another function, and we'll start off with two polynomials, we're going to do something called the product rule. This first example is just a demonstration that the product rule works. They want us to multiply this function out because these powers here are just 1. So I really wouldn't do product rule on this type of function. But we need another rule to use in conjunction with product rule to do some harder ones. So just know that in about a week or so, we would never do this by product rule. We would multiply it out and get the derivative using power rule. We'd make it a polynomial first. And that's what they're asking us to do right here. Then we're going to kind of come up with our product rule. So we're going to say if h of x is defined as one function times another function, so there's multiplication, it's not that polynomial type function where there's a bunch of things added together and there was no multiplication or division. Then the derivative of h is going to be f prime of x times g of x plus f of x times g prime of x. Notice that there's two terms separated by addition, and in each term you have multiplication of the two original functions, except one of them is going to be the derivative and the other one will just be the function itself, and then vice versa in the second term. It doesn't matter which term you write first because it's addition, and it doesn't matter inside the terms if you write the g of x first or the f prime of x first. So you can't really mess this one up quite like you can on the next rule we're going to learn. The only way you can mess it up is if you don't have your two terms, or you put the derivative of both in the same term. You got two terms. Each term should have the derivative from either one of the functions, and then the other part would be the non-derivative. So let's start applying that rule. Let's look at it for this function f of x. So this is like our first function, f, and then times another function, g, because you have this multiplication in here. So if I apply this rule, f prime of x is the derivative of 2x minus 3, and I use power rule, I just get 2. And then times, I recopy g of x, which is x squared minus 2x plus 1, plus, if I recopy f of x, I get 2x minus 3, times g prime, so by power rule on g, I go 2x minus 2. All right, and then from here we can simplify. We don't need to do that. That's how we do product rule. So why would we do this if, like I said, you can just multiply it out? So this is what this is talking about down here. In some functions, it's not possible to multiply out. You can see that your f here is x squared and your g is sine of x. But anytime you could multiply it out, you might as well, and then just do power rule. You're going to start deciding, once you get all these rules, which way is the fastest way to do it. All right, so it says apply the product rule to find the slope of the normal line to the graph of this guy when x equals pi. So we know to find the slope of the normal line, I need the slope of the tangent line, and then I just take the opposite reciprocal. We then know the slope of the tangent line is the derivative. So we got to start by finding the derivative. So our derivative of g, if I look at my first function, f is x squared, I'll go, the derivative of that by power rule is 2x times, I'll recopy the second function, sine of x, plus, I can recopy the first function now, x squared, times the derivative of the second function, cosine of x, because that's the derivative of sine of x. Now we want the derivative of the tangent line at pi. So if I plug pi into my derivative, that will give me the slope of the tangent line at the x value pi. So I've got 2 times pi times sine of pi plus pi squared times cosine of pi. So that's going to be equal to 2 pi times the sine of pi is 0 plus pi squared. And then the cosine of pi is negative 1. So it looks like I'm getting negative pi squared. That is the slope of the tangent line. So then, like I could think of that as over 1. So then that means that 1 over pi squared would be the slope of the normal line. At x equals pi. All right, let's move on. So use the product rule. We got a little practice here with product rule. So again, this is my, well, this is f of x, so that gets a little confusing. So I'll call this one g of x, and this one h of x, and you can see there's multiplication there. So the derivative here is going to be, if I do the derivative of the first, it's 3x squared. I recopy the second, plus recopy the first, times the derivative of the second. Then I'm looking to simplify if I can. So we are going to rewrite this as I can factor out an x squared, and I'll have 3 times sine of x. We do like to get our derivatives in factored form, plus x cosine of x. Keep in mind that you cannot multiply anything in here times this x. Like, you know, I can't multiply this x times that x because cosine of x means that's the angle. The angle is x. I can't take a multiply by cosine and multiply it in there. Just, you can't do that. All right, let's look at this next one. 3x plus 2 times cosine of x. So again, if this is my f times this is my g, I've got h prime of x equals, the power rule is 3 for f prime times cosine, plus recopy f times the derivative of the second one. I put this in parentheses so it doesn't look like minus sign. So now I'm going to rewrite this as 3 cosine of x, and then I'll say I'm going to distribute that negative sign to both of those. So I'll get minus 3x sine of x, and then minus 2 sine of x. So here we've got now this addition that breaks it into 2 terms. So I can do the derivative of each term independently. Of course, inside of the second term, I've got product rule because I've got one function f times another function g. I can't call it g because that's already called g, so I'll say f times h. So the derivative here is going to be 3 by power rule plus, now I got to do product rule on the second part. So the derivative of f is 1 times recopy the second, plus recopy the theta times the derivative of the second, which is cosine of theta. And then there's not much simplification that I can do here. It looks like it's just going to be 3 plus sine of theta plus theta cosine of theta. Let's do another one here. That's my f, that's my g. Because there's multiplication in between them, I do product rule. H prime of x equals the derivative of f times recopy the g plus the recopy the f times the derivative of g. So that's going to give me cosine squared x minus sine squared x. So I could leave that as is. Now you can start to get into what's more simple. I could make a substitution for sine squared of x. I could say that cosine squared of x minus sine squared is 1 minus cosine squared. And then I could simplify that a little more. So now I have cosine squared of x. I distribute my minus sign, minus 1 plus cosine squared of x. So I could say that it's 2 cosine squared of x minus 1, not plus 1. Minus 1. That's an s. All right, so I would accept either answer here at this point for this one. Find the equation of the tangent line. So this is more the same, but let's do it. So I need the derivative first of all, because I need the slope of the tangent line. So it's going to be, actually I'm going to use a little more room for this. So this is your first function times your second function here. So it's going to be the derivative of the first, recopy the second, plus recopy the first times derivative of the second. Notice I use parentheses here, right here, so I don't think it's minus sine of t. I could start simplifying, but I'm just plugging in anyway, so it could be futile. I'm going to say 2 times pi over 6 times the cosine of pi over 6 minus, because a negative times a t squared, so it'll be pi over 6 squared sine of pi over 6. All right, so pi over 6 is 30 degrees, so I've got 2 pi over 6. That's actually, sorry, that reduces to pi over 3. Cosine of pi over 6, that's the root 3 over 2 minus pi squared over 36, and then sine of pi over 6, that's going to be 1/2. So if I start simplifying this thing, I've got pi times root 3 over 6 minus pi squared over 72. Then I want to combine these with a common denominator of 72. So that means I've got to multiply by 12 over 12. So I'll get 12 pi root 3 over 72 minus pi squared. So then it's going to be 12 pi root 3 minus pi squared all over 72. That is going to be the slope of the tangent line, because that was plugged into the derivative. We also need the point of tangency. We get that by plugging our x value, or t value in this case, into the original. So g of pi over 6 is going to be pi over 6 squared. Cosine of pi over 6. Again, cosine of pi over 6 is root 3 over 2. So it's going to be pi squared root 3 over 72. So our point of, this is the slope. Our point of tangency is going to be, the x value was pi over 6. And the y value is pi squared root 3 over 72. So using those, I can write the equation y minus pi squared root 3 over 72 equals the slope 12 pi root 3 minus pi squared. That's a heck of a slope of a line, times x minus the x value. So pi over 6 there. Okay, let's move along here. Now we got to look at how to do this graphically. Those were from equations. What if I give you a graph of f and a graph of g and ask you to find some stuff? So they say here that if g prime of negative 4 is 2, what is the value of p prime of negative 4? So we have the graph of g, we have the graph of f. What the heck is p? If we read the instructions, it says here's the graphs of two functions, f and g. Let p equal f times g. And let r equal excuse me, x squared times g of x. Use the graphs to answer the questions that follow. So they want p prime of 4. So that means, first of all, I need to find p prime of x. So p prime of x, let me just recopy this first, what p of x is. I'll get rid of that prime. It's f of x times g of x. So if I do product rule on this, the derivative is going to be f prime of x times g plus f of x times g prime of x. Okay, and from here what we need to do now is plug negative 4 into that. So p prime of negative 4 will equal f prime of negative 4 times g of negative 4 plus f of negative 4 times g prime of negative 4. So I just go grab that information off of my graphs. So f prime of negative 4. I'm on the graph of f. I'm at an x value of negative 4. So I'm right here on the graph. Since the graph is linear, it's got a constant rate of change. So the slope of that line is actually going to be the slope of the tangent line, or the derivative at negative 4. So that slope looks to be negative 1. So f of negative 4 is f prime of negative 4 is equal to negative 1. Then I got to get g of negative 4. Then I go over to the graph of g. I go to negative 4. And this time it's just the y value because they don't want the derivative. So if I look at negative 4 and look up to the y value here, it looks like it is 6. I do the same for f of negative 4 and g prime of negative 4. G prime of negative 4 should come out to be, let's look at negative 4 here. Should be a line somewhere on the graph. So the derivative there, oh, wait a second. No, I don't know what the slope of the tangent line is there from the graph. That's why they had to give me this information here. So I know that that's actually 2. Because there's no way to know it from the graph if it's not a straight line. Or if it's not a line, I should say, with constant change. Then f of negative 4, if I look on the graph of f and just grab the y value, I get negative 1. So then when I do out this simplification here, I'm going to get negative 8 for my p prime of negative 4. And then it says, find the equation of the tangent line to the graph of p of x when x equals negative 4. Well, to write the equation of the tangent line, we need the point of tangency. And we get that by plugging negative 4 into p. And then we also need the slope of the tangent line. We get that from p prime of negative 4, which we discovered up above was negative 8. So the point of tangency means it's going to be f of negative 4 times g of negative 4, because p was defined as f times g. So I can use the graphs again. I can go grab f of negative 4 and g of negative 4, or I already found them in doing my product rule here, right? It was just 6 and negative 1. So it's going to be negative 1 times 6 is going to be negative 6. So my point of tangency on p is going to be negative 4, negative 6. My slope is negative 8, so now I can write the equation of the tangent line as y plus 6 equals negative 8 times x plus 4. Let's do this guy over here. It's a similar kind of thing. R is defined as x squared times g of x. So they want, if r prime of negative 2 equals 20, what's the value of g prime of negative 2? So what we're going to do is do a little solving backwards here. So if r of x is defined as x squared times g of x, I'm going to take the derivative of r, and the derivative of g of negative 2 should turn up in there, and I can solve backwards for it. So the derivative of this guy should be the derivative of the first function, which is 2x times recopy the second, plus recopy the first times the derivative of the second. So now I know r prime of negative 2 is equal to 20. So I can set this thing, I can plug in 20 over here, so I can say 20 equals 2. And this is when I plug, let's do it this way. This is getting sloppy the way I'm writing it. We'll just write it this way. R prime of negative 2 is going to be equal to 2 times negative 2 times g of negative 2 times negative 2 squared times g prime of negative 2. And they're asking me what is g prime of negative 2. So this is like my variable. I'm going to solve for it. Now, meanwhile, I know this whole thing is equal to 20 because they told me that up here. So I'm just going to write it over here. 20 equals, and I'm going to do the simplification as I go. Negative 4 times g of negative 2 I can grab off the graph of g. At negative 2, it looks like our y value is negative 3. This should have been a plus, not the times right there. So plus negative 2 squared is 4. And then times g prime of negative 2. I keep putting an x there, because that's the thing that I'm thinking of as my x that I want to solve for. So I multiply negative 4 times negative 3, I get 12. I subtract it from 20, I get 8. So then if I divide by 4, I get 2 equals g prime of negative 2. That was the question. If I look up at the graph of the g at negative 2, if I drew my tangent line in there, it's telling me that the derivative of that thing is a slope of 2. I'd buy that, the slope of that tangent line there. If I draw my tangent line, they're telling me this slope there is 2. I'd buy it. Find the equation of the tangent line to the graph of r when x equals negative 2. So since I know r prime, well, we'll do it this way. First, I need the point of tangency. That means I need to know what r of negative 2 is. And that's going to be, r was defined as x squared times g of negative 2. I just discovered that g of negative 2, oh no, that was g prime of negative 2, sorry. I can look on the graph to get g of negative 2, but I also used it in here. So I know it's negative 3 already. So then I get negative 12. So the point of tangency is going to be negative 2, negative 12. And then the slope of the tangent line, that's going to come from r prime of negative 2, which they told us up here is 20. So my equation is going to be y plus 12 equals 20 times x plus 2. That's not a 2, that's a 20. Okay, now let's go into how we do it from a table as well. I just got to charge my pen. It's getting low, I think. Give me a sec. I'm going to pause the video. Okay? Let's look at using a table of values. Notice for each of these three x values, I have f of x, g of x, f prime, and g prime. Estimate the value of f prime of 3.5. So first of all, I have to recognize this as the slope of the tangent line of f. So when they're asking me to estimate the derivative, I actually have to use the f table, not the f prime table. Okay? Because 3.5 is in between 3 and 4. Right? So using this table, I'm going to use these two sets of points here and do my slope formula and find the slope of the secant line on either side of 3.5. So I'm going to say, I'm going to do my slope formula for those points. So I say the derivative at 3.5, or the slope of the tangent line, is approximately the slope of the secant line, f of 3 minus f of 4 all over 3 minus 4, which works out to be 3 when you do that out. So there's our estimate. F prime of 3.5 is about 3. Remember, to estimate the derivative, we find the slope of the secant lines passing on either side of it. We do not use the f prime table. That's a key point there. Okay, so that was just a little review once you get these tables, because that's a common mistake. If q is defined as this function, what's the value of q prime of 4? Notice there's no q's anywhere on the table. So what I have to do is apply product rule to find the derivative of q. So 2 times f of x minus 4 times g of x, there actually isn't any product rule in this, because when 2 is just a constant, we don't have to apply product rule. I could think of it as the constant coming along for the ride times the derivative of x. Alright, and then same thing over here, negative 4 is just a constant that comes along for the ride, so times g prime of x. So then q prime of 4, if I plug 4 into the derivative, is going to be f prime of 4 minus 4 times g prime. I don't need those parentheses. G prime of 4. So I'm going to go up to my table under my x value of 4 and find out what f prime of 4 is and what g of 4 is. So it's going to come out to be f prime of 4 is 2 and g of 4 is negative 3. So I get 4 plus 12, I'm getting 16. That's what q prime of 4 is. That would be the slope of the tangent line. It would be 16 at the x value of 4. These are similar. This one is product rule now. So the derivative of p, if I think of this as my first function with a constant of negative 2 and that as my second function, I'm going to say that the negative 2 comes along for the ride times the derivative of the function. There's the derivative of the first times recopy the second plus recopy the first times the derivative of the second. Excuse me. So now if I plug 3 into that, so I've got all f primes and g's of 3. 3 is an x value on my table, so I use this row and I just grab those values, substitute in, and it should equal negative 16. This one wants the equation of the tangent line. So again, I can do product rule on v. So it's going to be 3x squared times f of x plus x cubed times f prime of x. If I do v prime of negative 1, well, let me say it this way. So now that I have my derivative, let's do it this way. The point of tangency is going to be v of negative 1. And so that's going to be negative 1 cubed times f of negative 1. I can go pull that f of negative 1 off the table. So that's going to come out to negative 2. You can do that on your own if you want to pause the video here and confirm how I got that. So then that point of tangency is negative 1, negative 2. And then for the slope of the tangent line, I've got to plug negative 1 into the derivative of v. So using this guy here, same thing, I plug negative 1 into it. So it'll be 3 times negative 1 squared plus f of negative 1 plus negative 1 cubed times f prime of negative 1. For these values here, I'm going to go nab the table, nab them off the table, and I will get 5 when I simplify it. So I don't know why that looked like square to me. There's my point of tangency. There's my slope. I can write the equation of the tangent line as y plus 2 equals 5 times x plus 1. I'm having trouble with my parentheses here. Trying to go too quick. How much time are we at here? Let's take a look. Okay, we'll be under half an hour. So k is defined as this. What is the value of k prime of 3? So that means the derivative. If this is my first function and that's my second function, the derivative of the first is 2 comes along for the ride, f prime of x, plus 3, the derivative of 3 is just 0. So that's my first, times, recopy the second, 3 minus g of x. So I see like 3 things times each other here, right? So you got to be careful. Plus, now I recopy the first, 2 f of x plus 3. That's one big factor. Times the derivative of the second. So the derivative of 3 is 0, and the negative sign comes along for the ride, and the derivative of g is g prime of x. So now I've got k prime of x equals, I don't really need to simplify any of this. I'm just going to go ahead and, I guess I could. Why not? 2 f prime of x times 3 minus g of x minus, I just multiply this minus sign to the front. I'll leave the g of x over there. So it's going to be, or I'll just bring the whole thing to the front. Minus g of x, g prime of x times 2f of x plus 3. So now I'm going to plug 3 into that mess. Go pull the relevant information off of the table and find out that the answer is negative 46. Again, you can pause the video and see if you can do that. That's product rule. Quotient rule is up next.